1. Introduction, the program's home. Welcome to the Intermediate C Programming course, beginning with Section 01, Advanced Pointers. Before we dive into complex pointer manipulations, we must first understand the environment where our C program lives and breathes: memory. When your program executes, the operating system gives it a dedicated region of random access memory, RAM. This memory region is logically divided into 4 main segments, each serving a distinct purpose for your variables and code. Understanding these 4 segments, text, data, stack, and heap, is the foundation for writing efficient, especially when dealing with dynamic memory and pointers. 2. Segment 1. The text segment, code. What it stores. This segment contains the actual compiled machine code or instructions of your program. The following are its key characteristics. First is about fixed size. Its size is determined at compile time. Second is about read-only. For security and stability, the operating system marks this memory as read-only. This prevents your program from accidentally or intentionally modifying its own instructions, which would cause a crash. Example: every function you write, every loop, and every line of executable code resides here. 3. Segment 2. The data segment, global and static variables. The data segment holds global variables and static variables, those variables whose lifetime is the entire duration of the program. About initialized data. It stores global and static variables that you initialize with a non-zero value in the source code. For example, integer global count equals 50. And about uninitialized data, aka BSS block started by symbol. It stores global and static variables that are not initialized explicitly, meaning their default value is 0. For example, static integer error flag. And key takeaway here is, variables in the data segment are fixed in memory throughout the program's execution and are accessible from anywhere. 4. Segment 3. The stack segment, local variables, and function calls. The stack is perhaps the most dynamic and critical segment for function execution. What it stores. It stores stack frames. A stack frame, aka function call information, stores the following things. It stores local variables. Variables declared inside functions, like integer x. It stores return addresses, function parameters, and registers are saved here. About its key characteristics. First is LIFO, last in, first out. It works like a stack of plates. When a function is called, its data, a stack frame, is pushed onto the stack. When the function returns, its frame is popped off. Second is automatic management. The stack is managed entirely by the C runtime environment and the operating system. You don't have to worry about allocation or deallocation. Third is fixed size limit. Stack overflow. The stack has a limited size. If your program makes too many recursive calls without returning, it can run out of space, resulting in a stack overflow error. 5. Segment 4. The heap segment, dynamic memory. The heap is the most important segment for intermediate C programming. What it stores, memory that is explicitly requested by the programmer during runtime. This is where memory for dynamic arrays and data structures like linked lists will live. The following are its key characteristics. First is manual management. Unlike the stack, the heap must be managed manually using special functions like malloc, calloc, realloc, and free. Second is longer lifetime. Heap data persists until it is explicitly released by the programmer using free, or until the program terminates. Third is no structure. The memory blocks on the heap are scattered and not guaranteed to be contiguous. Accessing them requires pointers. This is the memory segment we will focus heavily on in the next module, dynamic memory management. 6. Summary and transition. Now that we know where our data lives, we can look at how C allows us to jump around and manipulate addresses using pointers. Our next lesson is 1.2, Pointer Arithmetic, adding, subtracting integers with pointers.